Hi, this is week 2 for chemistry. Today we're going to go ahead and talk about nomenclature, which is naming molecules. In particular, we're going to be talking about inorganic compounds. Alright, so our agenda for today is figure out the rules for inorganic compounds and then do some practice problems. Our objective for this lesson is to have students be able to name these compounds. So let's go ahead and get started. Inorganic compounds are those compounds that are made from a metal bonded to a non-metal. So a metal and a non-metal bonded, that's referred to as an inorganic compound. The rules for naming these type of compounds is different as that from organic compounds and hydrocarbons, which we learned in an earlier lesson. So it's going to be slightly different. So here's some basic rules. First of all, you're going to need a periodic table for this lesson. Absolutely required. You use the periodic table to figure out the symbol of the element plus the oxidation number, which is a fancy word for the charge of each element. If the charges do not match, then you're going to have to do a little bit of extra work to get them to match because you want them to have equal numbers of positive and negative charges. So let's start with those oxidation numbers or charges. So on your periodic table, you want to go ahead and write down all of these numbers that you see on top right here. What do they mean? It means that all of these elements, hydrogen, lithium, sodium, and so on, have a positive 1 charge. Everyone in this column will have a positive 2. I'm going to skip over here. Everyone has a positive 3. Everyone here could either be a positive 2 or a positive 4. And then they become negative. Negative 3, negative 2, negative 1. And these guys at the end have no charge. They are neutral atoms. Now let's talk about this middle section. Those guys are referred to as the transition metals. The transition metals could either be a 1, a 2, or a 3. Because you don't know exactly if it's a 1, 2, or 3, you have to let the reader know what exactly it is. For example, let's talk about iron. There's 2 types of iron. Iron with a +2 charge and an iron with a +3 charge. The name for this iron would be iron with Roman numeral 2. So the 2 tells you its charge. And for the second iron with a +3, it'll be Roman numeral 3. So Roman numeral tells you the charge. Now you only use Roman numerals in the name when you're dealing with these transition metals only, because they could be either a 1, a 2, or a 3. What about someone like sodium, who is always a +1? So let me write that down, sodium +1. Do you have to put a Roman numeral for sodium? The answer is no, you do not. Sodium would not have a Roman numeral. Why? Because it's always +1. So you don't have to tell me what it is because, well, I know that it's always +1, so therefore I don't have to put that. So you don't put it either. Again, you only do that for the transition metals plus this column right here where carbon starts at the top, because it could either be a +2 or a +4. There are some exceptions. In chemistry you'll come across exceptions, and some exceptions are, I said, every single one of these guys in the middle, the transition metals, need a Roman numerals, well, except for silver, zinc, and cadmium. Those guys are exceptions because they're always +1 for silver, and zinc and cadmium are always +2. So you'll come across them, you'll notice that they do not get a Roman numeral because they're always that charge. So they're the only exception to that rule I said that they need a Roman numeral here in the middle. Alright, so now we got those rules done. Let's go ahead and do some examples. So for our first example, you go ahead and you get the name, and they say from the name they want you to go ahead and let us know what is the formula. Alright, so first we need to figure out the symbol for each element and the charge. Alright, so we will need the periodic table for that. So the first one, A, is potassium oxide. So I'm going to look for potassium, and you'll find it right here. It's K, so it's a symbol, and it's got a charge of +1. So I'm going to write it down here. So this will be A, potassium with a +1 charge, and it was oxide. Notice that the ending has been modified with an IDE ending. It's really oxygen. The IDE means that it's bonded to another atom. So it's really oxygen. So that's what I'm looking for. Oxygen is right here. It's got a -2 charge. I'm going to write it over here. Do the charges match? No, I have 1 positive and 2 negatives. So what I do, well, I need to add an additional positive so that way they match. So I need 2 positives and 2 negatives. So I'm going to add another K Notice I have 2 positives, 2 negatives, they match. Great. So our formula is we have 2 Ks. So you write a K with a small 2 on the bottom right corner. That means there's 2 Ks. And right next to it, an oxygen. There's only one of them, so I put it right here. But in chemistry, we don't put ones. So that will be our answer for letter A. Let's move along to letter B. On letter B, they say magnesium chloride. Alright, so again, we need to use the periodic table to figure out what is the charge of magnesium and of chloride. Again, chloride's been modified with that IDE ending. It is really chlorine that you'll be looking for in the periodic table. Alright, so magnesium, you'll find it right there. Mg has a positive 2 charge. And chlorine is here with a negative 1 charge. So it's magnesium chloride again. You want these to match. So the smaller one, you want it to go ahead and match the bigger number. So we need more negative 1s. There you have it. 2 negatives, 2 positive, they match. So how many Mg's do we have? Well, there's only one of them. So put Mg with a 1. We don't write that down. How many chlorines do we have? 2 of them. So just write Cl with a small 2 right there. And there you have it. Alright, let's move along to the next one. Aluminum oxide. Now this is going to require a little bit more work. It'll be letter C. In aluminum, you'll find aluminum right here. It has a +3 charge. And oxide, again, that's oxygen. The ending's been modified. Here it is, which has a -2 charge. Alright, at this point we have a +3 and a -2. Again, they do not match. So then what do? Well, then you add more atoms. Now some students at this point would say, well, if I just put an oxygen with a -1 charge, there we go, we have +3 and a -3. I got them to match. I would like to remind you that oxygen, though, doesn't come with a -1. Oxygen has only a -2. I cannot put -1, that would be wrong. So you gotta add an oxygen with a -2. Which students say, well, wait a minute, but that goes over. Notice that I have 4 negatives and 3 positives. And well, you just keep on going, adding more positives and more negatives until they match. So I have more negatives, so therefore I need to add more positives. Again, could I just put a +1? No. Aluminum has a +3. I cannot put a +1. Alright, so now I have 6 and 2. I'm sorry, 4. Gotta keep going until they match. Now you'll notice I have 6 positives, 6 negatives. Now I got them to match. I'm going to go ahead and count. How many of each do I have? I have 2 aluminum, so I'm going to put Al with a small 2 on the bottom right corner. And I have 1, 2, 3 oxygens. So that's our answer, 3 oxygens. That's how you would solve C, which is aluminum oxide. Now let's get into D and E. Notice that they have a Roman numeral. So I'm going to go ahead and solve those for you. Alright, so iron, Roman numeral 3. Iron, notice that it's right here. It's a transition metal. It could have been a 1, it could have been a 2, could have been a 3. So since you don't know, that is why they let you know. Oh, it's number 3. That's what that Roman numeral 3 means right there. Alright, so I'm going to write that down. Iron with a +3. Chlorine, I'm sorry, chloride is really chlorine. And there it is, so it's got a -1. So I need them to match, so I'm going to need more negatives and more negatives. Now I have +3, -1, -1, that's a -3. They match, so my answer for this one it is, I've only got 1 Fe, so don't put the 1. And I have 1, 2, 3 chlorines, so I'm going to write Cl with a small 3 on the bottom right corner. And there's your answer for iron chloride. Iron 3 chloride. Now, our last problem is lead, Roman numeral 4 oxide. Alright, so lead is right here. See, it could have been a 2 or a 4, so that's why they let you know that is Roman numeral 4. So I put it Pb with a +4 right there. And oxide is oxygen with a -2. In this scenario, I need to add more negatives, so I'm going to add another negative, and there we have it. We have 4 positives, 4 negatives, they match. Only have 1 PB, so I'm just going to write PB with a 1, which I don't write, and 2 oxygens, so I write an O with a small 2, and there's our answer. So that's example number 1. That's how you solve from the name to the formula. Now, up next is example 2. In this problem, they're going to go ahead and give you the formula and ask you to figure out the name. Some will be a little bit easier, other ones will be more challenging. Alright, so let's start with A. A is going to be a little bit more difficult than the other ones. We have Cu2O. The reason why this one's more challenging is because Cu, that's copper, there it is, it's in this middle block, the transition metals. And that middle block, it could be a 1, a 2, or 3. So we got to figure out what is the oxidation number and write it down as a Roman numeral. I do know that Cu is copper, so we begin by writing the name, copper, and leave some blank parentheses there where the Roman numeral will go. O is oxygen, but the ending is replaced. Instead of oxygen, you write oxide. Remember that IDE ending is when you have these 2 atoms bonded to each other. How do you figure out the Roman numeral? That's the part that is the bit of a challenge. Let's write down the formula. Cu2O. Alright, so I'm going to put down the 1 right here. And what we're going to do is going to move these subscripts to the top where the charges should go. So I'll move the 2 up here and the 1 up there. The first one is always positive, the next one is always negative, always. Alright, so can we say that in copper, well, copper is a +1. Well, almost, but before we say that, we got to double check that with the periodic table. And on the periodic table, notice that oxygen is a -2. So if that one is correct, then that one's correct. Now we know, oh, copper, it's got a +1. So I'm going to write down Roman numeral 1. So that's how you get the Roman numeral from the periodic table. Alright, next, our next example was AgCl. Alright, AgCl, it's Ag's right here, it is silver. Notice that it comes from the middle of the periodic table. So does it need a Roman numeral? Well, students will say, yeah, it's from the middle of the periodic table. But in chemistry, there are exceptions. I wrote them up here. Ag silver, no, it's always a +1, so you do not need to write down a Roman numeral for it. So you just write down the name silver and no Roman numerals required. The second atom is a Cl, so that's chlorine, which becomes, instead of chlorine, chloride. You're going to see that IDE ending for these guys when there's 1 atom present to bond it to it. Letter C. Letter C is AlBr3. If you look for Al in the periodic table, you find it right here. It's got a +3 charge. Notice though that there's only 1 type of aluminum, so therefore no Roman numerals required. So it is aluminum. And Br is bromine, which becomes bromide. And yeah, we keep modifying that ending when you have a single atom like Br right there. Up next is MgO. Mg is right here. Notice that it's not one of these middle block elements, so therefore it does not need a Roman numeral. So you just write down the name. Mg is magnesium. And it was MgO, so it is oxygen becomes oxide. Alright folks, so that takes care of the first column of going from the formula to the name. Now in the second column we're going to continue for E through H. We have a few more that have Roman numerals, so they're going to get slightly more challenging. E. CAF, does Ca, calcium, require Roman numeral? Let's check. There it is. Does it require no Roman numeral? No, because it always is a +2. So all I have to do write down is calcium. And the second element was fluorine, so it becomes fluoride. Next one, Cu Cl. There's Cu. Notice it is a middle block, so therefore it does need a Roman numeral. Copper, blank parentheses, we'll figure out in a second. And the second element was Cl, so it's chlorine. So we change it to chloride. Alright, the formula that was given to us was CuCl2. I want to put the 1. And remember what I said earlier, you get the subscripts at the bottom, move them crisscross to the top, so that'll be your -1. And up here is a +2. So is copper really a +2? Before you say yes, you gotta double check. Is Cl really a -1? You always check the negative value. Is Cl really a -1? You say, yeah. Cl is a -1, so therefore copper is a +2. So therefore I put Roman numeral 2 for the copper. Alright, let's continue. Letter G. FeBr3. Fe is iron. Iron could be a 1, a 2, or a 3. So I'm going to write it down. Iron, blank Roman numeral. We'll figure that out next. And it was Br, which is right here. It's a -1. That becomes bromide. But what's a Roman numeral? Well, the formula was FeBr3. Again, move the charges up. -1, +3. Alright, before we say, oh, it's iron 3, you've got to double check. Is Br really a -1? Yeah, Br is -1. Great, so if that's correct, then that one is also correct. Alright, and let's move along to H. Problem H, we have CrO2. I'm sorry, Cr2O3. Alright, so we look for it in the periodic table. And there's Cr. It comes from the middle, so it's going to need Roman numerals. That is chromium. Blank parentheses for the Roman numerals. The O is oxygen, which is oxide. So it is Cr2O3. I'm going to move this one up here, that one up there. So that's a +3, and that's a -2. Alright, double check. Is oxygen really -2? That's correct. So if that one is correct, and this one's correct, Cr, you put a Roman numeral 3. Great. We should do one more example, and in this one, I'm going to call it I. Yeah, it's not there. I'm going to go ahead and do one more. What happens when it is not correct? For example, PbO2. So you say Pb is lead. Here it is. It could be a 2 or a 4. You write it lead. O is oxide. So how would you figure out what it is? We're going to say that one goes up here, it's -1. That one goes up there, it's a +2. So you say, it's a Pb2. Do I put a 2 right here? No. Check it out. Oxygen should be a -2. But I have a -1 as the charge. So how do you turn the -1 into a -2? You multiply it by 2. And if I multiply this one by 2, I got to multiply that one by 2 as well. So what will happen then is this will become a -2 because I multiplied it times 2. And what happens to this guy? Well, same thing. It becomes a +4. 2 times 2 is 4. So this is actually lead 4. So that's how you would fix it. A little bit of multiplication so you can get the oxygen to be what it's supposed to be. In that case, a -2. Alright, let's move along. That takes care of all the examples, plus one extra that I added. Polyatomic ions. Now we're going to go ahead and take it to another level. Alright, polyatomic ions are groups of atoms put together. Alright, so these groups, anytime you have a group, you're going to put it in parentheses. So notice I put parentheses around all of these guys. Now, I want to draw your attention starting with nitrate here. Notice the ending. You no longer see, for a group of atoms, you don't see that IDE ending. The IDE ending is only when you have one single atom. For example, if I had let's go with N, that might be nitride with that IDE ending. But as soon as I add the oxygen to it, that becomes Up next, we're going to go ahead and move on to something more complicated. They're polyatomic ions. Polyatomic ions are groups of atoms. And these groups of atoms are usually written in parentheses around them, and the number of groups, you would put it outside of the parentheses. You'll see the names have changed. Instead of having that IDE ending, which you find it when you have one single atom, because you have a group now, you will come across that ATE ending. So instead of sulfide, it'll be sulfate. Instead of bromide, it'll be bromate, and so on. And notice that they have an oxygen. All of these guys with an ATE ending have an oxygen. I added two more. There's hydroxide and ammonium. Ammonium is the only one right here with a +1 charge. Alright, so those are all of our polyatomic ions. And we're going to go ahead and use this. And you want to keep this slide handy as we go through the names, as well as your periodic table. Alright, so example 3. In this one, they give you guys the name and ask you, can you go from the name to the formula? Alright, so let's get started. Example A. In example A, they say calcium nitrate. So again, you're going to need your periodic table handy. Calcium, you look for it. It is in the second column, so you give it a +2 charge. And nitrate, notice that ATE ending tells you that it's a group. Alright, so you look for it, and there it is, nitrate. NO3 with a negative charge. That means that there's a nitrogen with 3 oxygens attached to that nitrogen, and this whole group has a charge of a -1. Alright, so how do you solve for this formula? You do more or less the same thing, where you want the numbers to match. So I only have 1 negative and 2 positives. So I need more negatives. So I'm going to add another nitrate. See, now I have +2 and a -2. They match. Great, that's what I need. So I need 1 calcium, so I'm going to write down the answer. See it with a 1, which we know we put once. And how many nitrates? 2 of them. Now I mentioned this earlier. Groups, you have to put them in parentheses. So there's my group. And how many of them do I have? 2 of them. So in the bottom right corner, outside of parentheses, there's a 2. Meaning that I have 2 groups of NO3. Alright, so there's our first one. That is calcium nitrate. The next one, sodium sulfate. Again, you need your periodic table. You look up sodium. And on the periodic table, you'll find sodium has a +1 charge. Sulfate, you will look in your table right here, and there it is. Sulfate, it is 1 sulfur with 4 oxygens attached to it, and the whole thing's got a -2 charge. In this scenario, they're mismatched again, so you need to add another sodium so that they match. Therefore, I have 2 positives, 2 negatives. Now they match. Now I ask you, count them. How many NAs do you have? You say, well, I got 1 and 2. Great, 1 and 2. So I'm going to write an NA with a small 2 in the bottom right corner. Now this is a group, so what did I say about groups? Well, I said put it in parentheses. SO4. How many of them do I have? 1. Great. Though that's not written 100% correctly. It's not bad, but it's also not good. Why? Well, something I said earlier, well, chemistry's got exceptions. Here's an exception. You see there's a 1 outside of the parentheses? Do we write 1s? No, we do not. And if we're going to erase the 1, then there's no need for parentheses. So this will be the actual formula for how it's written for sodium sulfate, and this one, calcium nitrate. So this is the answer for A and B. Alright, let's go ahead and move along to C. In C you have ammonium hydroxide. So letter C, ammonium hydroxide, you have ammonium right here at the top, which is NH4, that means it's a nitrogen and with 4 hydrogens attached to it. And the whole thing's got a +1 charge. And oxide, which is oxygen with a -2 charge. And again, you gotta look at your periodic table to get these charges. Alright, what's my goal? Get the charges to match. Alright, so we have a +1 charge on the left. We need to get it to be match the 2. So I would add another NH4. There you go. I have 2 positives, 2 negatives, they match. How many ammoniums do we have? We got 2 of them. So I would write the group NH4 in parentheses. And again, there's 2 of them. So put a 2 outside of parentheses on the bottom right corner. Oxygens, there's only 1, so I put it right here. Do I put the 1? Again, we don't put 1s in chemistry. But that's your answer right there for ammonium hydroxide. Alright, up next is letter D. That one, it has a Roman numeral. Lead, Roman numeral 2, phosphate. Now the Roman numeral, remember, it tells you the charge. So I don't even have to look it up in the periodic table. I know that lead is Pb, and I'm going to put a 2 up here because of that Roman numeral 2. Phosphate, we'll look it up, you'll find it right here. It is a phosphorus with 4 oxygens attached to it, and this whole thing has a charge of -3. Alright, so now we have a mismatch right there, so we keep on adding until they match. We're going to add another Pb, that gives us 4 and a 3, still no match. So I'm going to add another Pb, 6 and a 4, not a match. And finally, I'm going to add another Pb. Now we have 6 positives, 6 negatives. Now we have a match. So let's write down the formula. There are a total of 3 Pb's, so I'm going to write it down Pb with a 3 right here. And there are 2 phosphorus, so I'm going to write it down, it's a group 2. Alright, why the 2 outside? Because there's only 2 phosphates. Alright, so that goes ahead and takes care of letter D. Let's move along to letter E. Letter E, they give us lead, Roman numeral 4, hydroxide. So, Roman numeral 4, hydroxide. In hydroxide, you'll find it right there. It is a very small group. It's only made up of oxygen and hydrogen with -1. So 1 oxygen, 1 hydrogen. It's a tiny group, but it is a group nonetheless. So you still need parentheses around it. Alright, let's see. We got a +4, -1. So there's not enough negatives. We need to add more negatives until they match. So that means I got 4 negatives matching the 4 positives. There's a formula. If I ask you how many PVs, you say, well, there's only 1. So PV with a 1 right there. How many OHs? It is a group, so it needs parentheses. And there's 4 of them. 1, 2, 3, 4. So I need to put the 4 outside. Alright, so that takes care of the E. Next one up is silver nitrate. And in silver nitrate, I want to remind you guys that silver is always +1. So letter F, silver, always +1. Nitrate, when you look for it, you'll find it right there. NO3 with a -1. Check it out, they already match. Great, so what do I have to do? Do I need to add more AGs? No. Do I need to add more nitrates? No, I do not. It's done. So there's only one of these and one of those. You essentially just put them together. And that is your answer for E and F. Alright, so those are polyatomic ions. Now for our next example, we're going to go ahead and move along and do the opposite, which in this scenario, they give you the formula, and now you have to figure out what is the name of it. Again, if they got Roman numerals, you got to do extra work and figure it out. If they do not have Roman numerals, then it makes your life very simple. You just write down the names you see. Let's start with A. For A, you have Na2O. Na is sodium. It comes from the first column of the periodic table. No Roman numerals required. So So you just write sodium, O, so oxygen, which is change to oxide. That's it. The next one, letter B. K is potassium. It also comes from the first column of the periodic table. No Roman numerals required, so you just write down potassium. No Roman numerals. CO3 is a group. That CO3 is, let's see, there it is, carbonate. And that's it, because there's no Roman numerals, you don't have to do any additional work. MgSO4. Mg is magnesium, no Roman numerals required. SO4 is sulfur with an oxygen, so it's sulfate. Done. Alright, but letter D, that one's going to require Roman numerals, and E and F as well. So, let's go through those guys. Letter D, it is iron. Now, iron is in the middle of the periodic table, so it does need Roman numerals. So I'm going to put a blank spot right there to where it goes. Cl is chlorine with oxygen, so it's chlorate. It's a group. Alright, what do I do now? I'm going to rewrite it. Fe, parentheses, ClO3, parentheses 3. Alright, there's no number there, that means 1. And just like before, I'm going to get the numbers outside. If this parentheses, it's outside, and crisscross them up there. So that's a +3, and that's a -1. So we say, oh, it's iron Roman numeral 3. Maybe, but before we say that for a fact, you got to double check. Is ClO3 really a -1? So let's go ahead and check that. It is ClO3 really -1? Yeah, it is. So if that one's correct, that one's correct. So it is iron, Roman numeral 3. Last but not least, SnSO4. Alright, now this one's a little bit of a complicated problem. Alright, first of all, let's start with the name. Sn is tin. Let me find it on the periodic table. There it is, Sn is tin. It could be a 2 or a 4. Alright, so let's take a look at it again. So notice tin. It needs Roman numeral because it could be a 2 or a 4. SO4, that's a group. It is right there, sulfate. And to figure out the Roman numeral, this is a trick question. Let me show you guys what a lot of my students would do wrong. They would say, well, I know there's a 1 right there. So that goes up there, and that's a -1. Goes up there, that's a +4. And that is wrong. That 4 should not go up there. It's like, why? Oh. The answer for that is because, remember that SO4 is a group, so it needs parentheses. So why did I not put parentheses on it? Because that's a 1 outside. Alright, so that's why I didn't have parentheses. So watch out for that. A lot of students will go and get that 4, put it up there. It's like, no, that's, the SO4 is a group. There's no parentheses, that means that there's only 1 SO4, and the real number that's outside is a 1, so you go up here, +1. That one up here, it's a -1. Great. So Sn is a +1. Well, before we can really say that for sure, we gotta double check. Is SO4 really a -1? Let's check. SO4, no, it's a -2. So what do? We double this one. Now it's a -2. And if we double that one, what do we do with this one? Same thing, we double it. So it's a +2. It is tin, Roman numeral 4. This one very tricky because of the lack of the parentheses, and also gives you the wrong oxidation number, the wrong charge. Alright, so that is letter F for example 4. That takes care of this lesson on inorganic nomenclature. Thank you for watching.